Okay, I got cut off by the memory card running out of space before I got all the way through this. But what we said was, I simply claimed that this is equivalent to this. Now, I'm not going to erase this and then rewrite it. I'll just go with what I have. Let's just multiply this matrix by this column vector. What do we get? I get 2 times x, because x just stands for some number. So it's this number times this number, whatever it might be. That's going to be 2x. And then I've got to add -5 times y. And that is, of course, minus 5y. So I have 2x minus 5y. This row times this column gives me this. And 4 times x and -1 times y gives me 4x plus a -y, or just 4x minus y. Okay? And that has to be equal to this vector, -7, 2. Now, what does it mean for this to be equal to this? Now, this contains only 2 numbers, one number here, one number here. The number that's here is whatever you get when you plug in the value of x and y and evaluate 2x minus 5y. And if this is going to equal this, that has to be equal to -7, so 2x minus 5y has to be equal to -7. And this number has to be equal to this number, so that 4x minus y, whatever that is, for the solution x and y, has to equal 2. So we get 4x minus y equals 2. Well, what's this? This is just the same as this. Now, we can, well, we've expressed the system of equations as a matrix equation. Okay? This matrix equation is of the form AX equals B, where x is a column vector that consists of both x and y, and b is the column vector over here that you get from the fact that you're using x and y as your variables in your simultaneous equations, and the fact that the -7 and 2 are on the right-hand side of your equal sign. How would you solve an equation like this? Well, you might want to say, okay, so x should be equal to b divided by a. Does that work? Well, no, it doesn't work, because while we have a definition of matrix multiplication, we don't have a definition of matrix division. So, no. There's no such thing as matrix division. So we're going to say, no, we can't do that. But the thing we can do is we can multiply both sides of this equation by the inverse of A. Okay, now, not every matrix has an inverse. There are restrictions, but when a matrix does have an inverse, it's not all that hard to calculate. And for a system of 2 equations, a 2 by 2 matrix, it's really easy to write down the inverse matrix. So we can say, okay, well, how about A inverse times A times x equals A inverse times B. Now, A inverse times A, I'm going to get a little bit non-rigorous here, but A inverse times A, just like a reciprocal, A inverse times A times x just gives you x. I don't like to use the word cancel. I'm totally opposed to it because people do it wrong. But in a sense, then the A inverse and the A kind of cancel out, okay? You won't hear me use that term very often. So x is just a matrix multiplication, A inverse times B. And that's a very, very handy thing. Okay, so except that we don't have division by matrices, But for certain matrices that are easy to identify, we do have an inverse matrix that behaves kind of like a reciprocal, but for different reasons. We can do this, and we can solve this system by just writing down this matrix equation, and then the xy is going to be the inverse of this matrix times this. Now, I haven't told you what the inverse of the matrix is, but this is a very, very neat and handy thing. So we see that the idea of simultaneous equations and matrices meld together into something that you're going to really like. Okay?